All right, good morning. My name is Aaron Match. I'm a postdoc at NYU. Today I'll be presenting work that I did with Stefan Fugler-Staller at Princeton during my PhD. This is work on the decade, the Quasi-Biennial Oscillation Faltered. I'm talking about this most recent decade. Have disruptions provoked a crisis in QBO science? To start, let's have a look at the QBO. This is zonal mean zonal wind with the annual cycle removed. This is Meritu data monthly, and what you can see is that most anomalies in the zonal mean zonal wind kind of flicker in and out of existence, except for this very coherent pattern in the tropical stratosphere. This is the Quasi-Biennial Oscillation, the QBO. It's a descending alternating pattern in winds with a period of about 28 months. The QBO is a wave mean flow interaction. It's driven by waves which originate in the tropical troposphere, propagate up, and dissipate as a nonlinear function of the background flow so as to amplify that flow and cause the mean flow anomalies to descend. Now, this wave mean flow interaction mechanism was distilled back in the 1960s and 70s. Here's a schematic for the classical one-dimensional model of the QBO from Plum in 1977, where you have a one-dimensional stratosphere, and impinging on that stratosphere are two gravity waves of equal and opposite phase speed, which dissipate so as to amplify the flow and cause it to descend. And this one-dimensional model is our QBO paradigm. It's a legacy going back to the 60s and 70s. Now, the QBO was discovered in the 1950s, and up until about this past decade, it was very reliable and predictable. But recently, some aspects have come under question. It was argued that the QBO was weakening in the lower stratosphere, and then watch this. Here's a QBO disruption. I'll show that again in 2016. And there was another QBO disruption in 2020. And these disruptions were not expected. They were profound deviations from the typical QBO behavior. The prospect was raised whether the QBO was headed into a death spiral. And so it has caused us to have to go back to the drawing board and ask whether we have to break some of our paradigmatic understanding to account for these disruptions. So here's a look at the disruptions in observational data. Typically, the QBO winds propagate from the top of the stratosphere all the way down to the bottom. That's what it did for the first 60 years. But then during the 2016 and again in 2020 disruptions, the QBO did two things that it had never done before. There formed easterly winds in the interior of the QBO domain, which subsequently descended. And above those easterly winds, there were wind anomalies which ascended, whereas previously all the wind anomalies in this region had moved downwards. Now, how we make sense of this formation and ascent has big implications for how we think these disruptions will affect the predictability of the QBO and the strength of our paradigm for the QBO. So looking first at the formation, there are two proposed mechanisms for this formation. The first one is triggering by planetary waves. These are waves of mid-latitude origin which propagate into the tropics, dissipate, and accelerate the wind to be easterly. And now if the formation is by this triggering, that means that the QBO is sensitive to mid-latitude dynamics in a way that was not previously appreciated. It also means that the near certain predictability of the QBO, with skillful forecasts going out to a year or more, might be in some cases truncated by this triggering process, which is happening at synoptic timescales of weeks. It's also been proposed that perhaps the formation could be indicative of a bifurcation towards a chaotic QBO. If the formation does reveal such a bifurcation, this could really throw QBO science into crisis. It could make it much harder for us to leverage the QBO to make subseasonal to seasonal forecasts of surface quantities, which we like to be able to do. And the prospect was raised, as I said, that if the QBO could be heading into a death spiral, which would mean we'd have to fully recreate our QBO paradigm, perhaps. Turning now to the ascent, it has been proposed that the ascent was due to anomalous upwelling. We're going to push back against this idea. I'll note that the upwelling was stronger than normal, a little bit stronger than normal during the 2016 disruption, but it actually wasn't really stronger than normal during 2020. So we're going to have a different way of accounting for this ascent. Broadly speaking, QBO disruptions have been thought to expose model deficiencies. So what I'm looking at in this talk is to what extent do we need to break or revise our QBO paradigm to account for these surprise events. And let's start with what caused the formation. I'm going to argue that the formation was due to triggering by planetary waves. I'm not the first one to argue this. When we looked in reanalysis, we found that the two QBO disruptions followed the two largest triggering events in QBO history. This is as measured by the 4-month sum of the horizontal eddy momentum flux divergence at 40 hectopascals in the QBO region. During 2016, this horizontal eddy momentum flux divergence decelerated the wind by 11.5 meters per second, which was sufficient to reverse the sign of the wind. This was the largest triggering in the QBO or in MERA2 history, and the second largest triggering occurred during the 2020 disruption. So I'm going to argue against the notion that the QBO disruption is indicative of a bifurcation towards chaos. Here's a figure from a paper by Renaud et al. 2019, a fascinating figure showing a route towards chaos in the classical one-dimensional model of the QBO. Really cool work, and it was suggested that maybe this could that the QBO disruption indicated that we were somewhere in this part of the regime heading towards something quasi-periodic or maybe eventually even chaotic. But when we had a look at the Earth-like QBO parameters, it seemed to us that the QBO is deep in the period 1 regime. Taking our QBO model, you have to increase the wave stress which drives the QBO by a factor of 8 in order to get one of these bifurcations. And by that time, the QBO period has decreased from 800 days to an unrealistic 150 days. So we think we're very far from such a bifurcation. So we think it was triggering, which formed the easterly winds of the QBO disruption. Next, what caused the ascent? And in particular, is anomalous upwelling, this previously proposed mechanism, necessary for that ascent? And to answer that question, we're going to use the classical one-dimensional model of the QBO. And we're going to run that one-dimensional model with constant upwelling. So by construction, there's going to be no anomalous upwelling in the simulation. And we're going to see what happens to the winds above a level at which we trigger the formation of a disrupted shear zone. And what we see is we see ascent. Westerly winds are moving up. And this is under constant upwelling, and it suggests that it is the wave mean flow dynamics of the QBO, along with the climatological upwelling, which leads to this characteristic ascent of the disruptions without needing to invoke anomalous upwelling. If we just compare the disruption in the one-dimensional model to the disruption in MERA2, it's a very favorable comparison. All the key features of the observed disruption are recovered in the one-dimensional model. And so it suggests that triggering is a parsimonious mechanism for producing the full response of the disruption. Now, how are we getting ascent under constant upwelling? How can we get that without having anomalously strong upwelling? Let me explain that in terms of the one-dimensional physics of the QBO. So here's a typical QBO wind profile. Black is the zonal wind, and the positive phase speed wave is dissipating to amplify the westerly winds. The negative phase speed wave is dissipating to amplify the easterly winds. Now, what happens during a disrupted QBO is that the triggering reverses the winds in the lower part of the domain. And now this negative phase speed wave is dissipating to amplify the triggered shear zone instead of propagating up into the upper half of the domain. That leaves the whole upper part of the domain shielded from the wave driving, which typically causes the QBO to descend. And in the absence of this wave driving, the climatological upwelling is able to cause these wind patterns to ascend. Now, typically, the climatological upwelling is not strong enough to overcome the wave mean flow mechanism of the QBO. It was really the reconfigured wind profile which led to the dominance of the climatological upwelling. All right, so what caused ascent? It is climatological upwelling of shielded winds. So wrapping up here, have disruptions provoked a crisis in QBO science? It's been argued that disruptions are in some sense indicative of a weakening of the QBO. But we've shown here that we can recover all the features of the observed disruption using the classical 1D theory. And we can do so while leaving the classical wave mean flow processes intact. So we don't think there's any need to revise that legacy of QBO science going back to the 1960s. It is true that we think triggering was essential to the QBO disruption. So the fears that the QBO might now have reduced predictability due to possible synoptic influences, I think, are borne out. Although, of course, the reduction in this predictability is very sensitive to the triggering frequency, which is itself very uncertain. The prospect was raised that the QBO was headed for a death spiral, yet in Alan Plum's classic paper, he showed that the QBO emerges from a wave mean flow instability. Even infinitesimal anomalies in the wind are amplified into a mature QBO oscillation. So we do not fear that the QBO, that these events are indicative of a death spiral. And lastly, the prospect was raised that disruptions expose model deficiencies. We've shown that in response to triggering, the 1D model reproduces all the key features of the disruption. So we think that rather than undermining our legacy of QBO science going back to the 1960s, the disruptions actually provide an out-of-sample test in response to a triggering that was never expected to occur, but in response to which the model performs very well. So rather than being a crisis of QBO science, we think disruptions are a triumph of QBO science. Thank you, and I'll be happy to take questions. Yeah, so the source of the Rossby waves for the first disruption are sourced to the northern hemisphere. Second disruption has been linked to the southern hemisphere. It's not clear that the source of the waves is what was really exceptional about what allowed these waves to trigger the disruption. It seems that it was their propagation and dissipation in the deep tropics, which was very exceptional about them. I think there are still some basic questions about how these waves evolved to trigger the QBO disruption. The triggering is not really reproduced well in models. And if you look in MERA 2, what we found is that the analysis increment, which is the extent to which the reanalysis system is struggling to account for the observed state, was largest during the triggering of the 2016 disruption. That was the largest analysis increment on record. And it was of a comparable order to the triggering itself. So it suggests that these assimilation systems might be struggling to get exactly what was special about why are these waves dissipating rather than just passing through the tropics and perhaps dissipating in the opposite hemisphere.
I had more or less the same question, but I'll turn it around a little bit. For those of us who live in the lower troposphere, was there any sign that something special was going on in 2016 or 2020 in terms of these waves that provoked the change in the QBO?
Yeah. So, I mean, there certainly was a strong El Nino in 2016, and people have wondered about the causal influence of that El Nino going up into the perhaps the triggering of the QBO disruption. In terms of what the QBO disruption did to the lower troposphere, I'm actually not sure which way you were, or maybe you were asking for both ways. The winds at the bottom of the QBO seem to be quite important for the QBO teleconnection. So the disruption kind of reshuffled those winds. So it threw out of phase some of the teleconnections that we tend to expect. And if that didn't answer your question, I'd be happy to chat more.
Okay, we're out of time, so maybe we can move on. Sorry.